Got it. Thank you. All right. So today we're going to cover two topics. The first one is the proposal for um, broadening the use of LFH horizons in the Canadian system. And the second one is going to be looking at the addition of a new subgroup to the organic cryosols. And so the first one up is the LFH horizons. And Jim Miller is not able to be here today to present. And I was not able to get a hold of any of the co-authors either on the paper. So I had some discussions with a few folks, and I put together a slide deck last night based on the paper. And so I'll go through what was in the proposal, and then we can have a discussion after that. We won't be able to ask directly any questions of Jim and co-authors, but I don't think that that's a problem. So let me figure out how to share. All right, move this over. And all right, can everybody see my screen? Are we good?
Yep.
Okay, perfect. Thanks, Ben. All right, so taxonomic criteria for applying LFH horizons to include non-forest soils. So this was Miller, Chinasik, and McNeil, and the paper again is on the Google Drive, but everybody did their homework, right? So let's skip ahead. So the definition of LFH horizon changed between what was the precursor to the modern Canadian system and the third edition. So in 1970 and 74, the system of soil classification for Canada is what it was called. Organic horizons may be found at the surface of mineral soils or at depth beneath the surface in buried soils or overlying geologic deposits that contain more than 30% organic material. And LFH horizons are organic layers that were developed under imperfectly to well-drained conditions. And that was the definition. With the update to the third edition of the Canadian system in 1998, organic horizons were developed, or the definition was changed, and it changed a little bit, but organic horizons developed primarily from the accumulation of leaves, twigs, and woody materials with or without a minor component of mosses. And so we notice already that it's very much forest focused. And then the additional sentence was that they are normally associated with upland forest soils with imperfect drainage or drier. And so there's a real emphasis in the new definition that LFH materials are restricted to upland forested sites. And so the problem that was identified in the paper is that this narrower and more restrictive definition implies that the LFH is only applied to forest soils. There have been many occurrences of LFH horizons being described or observed in the field in non-forest soils under agriculture and other land use types as well. And they are proposing that the taxonomic criteria for applying LFH horizons needs to be broadened to include non-forest soils. So a little bit of rationale in terms of kind of the importance of LFH horizons and why they should be properly characterized in the field. Short-term benefits of LFH horizons, they include things like improved crop production under certain conditions, not all conditions, reduced raindrop impact, greater infiltration, reduced runoff and erosion, reduced crusting and compaction, and moderation of soil moisture. In terms of long-term benefits, there are some others like increased soil organic carbon pool and nutrient cycling, improved soil quality, reduction of non-point source pollution. There's certainly some impact on greenhouse gas emissions, increase in soil biodiversity, and improved soil health. So there's a number of kind of important benefits provided by the LFH horizon, and therefore an argument that it should be better defined in all systems. And so as part of the paper, Jim reached out to a number of pedologists practicing kind of across the country to get, I guess, what I've called expert testimony. So, you know, from BC, I won't go through these necessarily in great detail, but I think the story is that, you know, practicing soil scientists have observed LFH horizons in non-forested settings across the country, more so in the West, and that might just be because of the, I guess, greater adoption of no-till systems and earlier adoption of no-till systems, and probably more rangeland and pasture-based systems than in the east. But certainly BC and Alberta here, you can see that these LFH horizons are observed in non-forest soils. I just grabbed some examples. This is, a thin LFH horizon in a 30+ year no-till system. Much thicker LFH here, really more of like a thatch layer in a fescue native prairie in Alberta. A pretty thick LFH horizon here as well, as well, at least what they're defining as an LFH in an irrigated pasture system. This as well as in Alberta. And so if we keep going kind of west to east, you'll see that Saskatchewan, Manitoba as well. People that were interviewed, confirm the presence of LFH outside of forested areas and in the agricultural land use systems. But you can see kind of as we go east, things kind of drop off. So, here in Ontario, it's probably less typical, but it could be seen in pasture forage systems. And one example in Ontario is specialty crops, so vegetable and ginseng production often use fairly thick layers of mulch to protect the soil and the plants. And so so that's kind of I guess suppose maybe an anthropogenic accumulation of organic materials at the surface. In Quebec, it was described as not really being seen in agricultural soils. And then in New Brunswick, generally not under potato and pasture, which are the dominant agricultural practices, although there are some occurrences, but just not as widespread, I guess, as in the West. And so I think we certainly can see that there's a bit of there's definitely a regional issue on the go here. And then this was kind of the summary table that they put together towards the end of the paper, which kind of outlines the presence of surface organic soils associated with specific soil orders and agricultural landscapes. And we can see here certainly, so Trinizemic and Solonetzic soils, which are grassland soils, vertisolic soils as well, typically, and then regasols. I think we can also see in this the regional differences again. There's not really a mention of luvisols here, although in southern Ontario it's mostly gray-brown luvisols where we would see potentially some of this occurring. And then I imagine there's in the luvisols, the gray luvisols in the prairies that are kind of the fringe areas between the boreal and the grasslands as well, we would see. And so in any case, we can see here kind of as a function of the type of system, whether or not there's accumulation of materials at the surface, and we can see fairly high in Chernozem and low or variable in the other three soil types. And certainly, depending on the type of agricultural system, so no-till rangeland and irrigated pasture, are going to have different rates of accumulation or potential rates of accumulation over time. So this wasn't in the paper, but I thought I would add some of this because there has been some discussion around the use of horizon nomenclature from other systems and why our system looks different. So I thought I would just put this in for context ahead of us having a bit of probably of a discussion on this. So in soil taxonomy, which is the USDA system, they don't recognize LFH horizon. They recognize all of their organic horizons as O horizons. And you can see here OI is first which would be the equivalent of an F or OF for us, so fibric, OE, which is mesic, and then OA, which is going to be humic. And so again, they don't recognize LFH, they just use O, and they don't differentiate between whether that organic material at the surface originates from an upland accumulation or imperfectly drained or better, or if it's from a wetland organic material accumulation, so something that's saturated. If you look quickly at the world reference base, organic materials, you can use either H or O to characterize those horizons. Interestingly, the H in the world reference base is an organic horizon that is saturated with water for a prolonged period. And then the O horizon are those that are not saturated for a prolonged period. And again, the same modifiers are used I, E, and A in the FAO system, and they can be used with either the H or the O horizons. I looked quickly at the Australian system as well, because their system tends to be fairly well aligned with the Canadian system, but I've discovered that maybe not in terms of the horizon designations. And so they have O and P horizons to denote organic materials. O is again dominated by the presence of organic matter in varying stages of decomposition, and they just separate their O's into O1 and O2 horizons. So O1 is undecomposed matter, and O2 is organic debris in various stages of decomposition. And so note that the cutoff here is 20% organic carbon for the O horizons. And then they've got a bit of an odd one, or at least I find it odd, a P horizon. They're distinct from the O horizons that they form under waterlogged conditions. Again, you can use a P1 and a P2, which is kind of the same 1 and 2 as the O horizon, or the meaning is the same at least, but their P horizons are limited to soils that contain between 12 and 18% organic carbon. And it says depending on clay content. So to me, the P horizon in the Australian system is a little bit odd. I hadn't really ever looked at this before. And then so the paper, so back to what Miller had proposed, is that kind of two different revisions were possible to the definition of the LFH horizons. The first one is to reestablish the terminology for applying LFH horizons that was defined in 1970. The second is to broaden the definition that exists in the current system for when we can apply LFH horizons to include non-forested soils. And so they had put together this text, I guess, for the proposed kind of definition of the new definition that would go into the fourth edition of the Canadian system of soil classification. And so the LFH organic horizons are developed where surface plant residue accumulation exceeds decomposition in one, upland forest and natural uncultivated ecosystems. So that's leaves, stems, twigs, woody materials, minor amounts of mosses, grasses, or two, in agricultural ecosystems, leaves, stems, and roots from grasses and forbs or other crops, including orchards and vineyards, and harvested plant residues such as straw, chaff, leaves, stems, husks, etc. Or three, in other upland scenarios such as reclamation, recreation, and urban land uses, various accumulated organic residues. Upland soils are associated with imperfect drainage or drier conditions. Inclusion of the LFH horizons will depend on the discretion of the field pedologist or researcher with respect to the purpose of the survey or scientific study and the scale and degree of precision required across the landscape. So we'll revisit that in a minute when we have some discussion on this topic. I just also wanted to point out some other recommendations that were in the paper. The first one is that we should explore the use of lowercase suffixes for LFH horizons that describe humus form classification, so more, motor, and mole. And those should be considered in any revision to the LFH criteria. So I think that one is a little bit out of scope as to what we're trying to achieve today by reviewing their main, I guess, recommendation, but I think it's worth having some discussion on that too. The second recommendation that they made there as well was that all of the soil profile diagrams be altered so that they reflect the potential of LFH horizons in these non-forested soils. And so everyone will be familiar with that. I don't have my book in front of me, but those are the soil profile example soil profile diagrams at the start of every soil order chapter in the CSSC. And then also that the LFH horizons need to be added to the common horizons in the subgroup descriptions. So below every subgroup in the Canadian system of soil classification, there's a little subheading called common horizons, and it gives you a list of horizons, including the diagnostic horizons for every subgroup. And so their recommendation there is that for these non-forested soils that we also add LFH as potential surface horizons that could occur. All right. And so with that, we are going to have a discussion. I'm going to stop sharing for this part, unless we need to see what I was showing, but I don't think that we do. get out of my presentation mode. There we go. Okay, so I think we can just use the we can use the reactions button, put up hands. I see Richard already has a hand up and Constantine as well. So I'll try to moderate the discussion and go that way. I didn't see whose hand went up first, so I'll just call on Constantine to please go ahead, and then we'll go to you, Richard, after that for discussion.
Yeah, I would like to bring to even broader scope of ecosystems in higher mountains where it is not technically forested, but rather shrubby, or maybe even grassland ecosystems, but up mountains. LFH horizons are quite typical, and they would contain woody debris, but that's non-forested and still common, going all the way up to alpine areas.
Okay, so Constantine, just essentially your point is, regardless of land use, we should be able to use LFH horizons to describe organic materials that are occurring at the surface or below the surface. That's
yeah.
Yeah. Perfect. Okay, thank you, Constantine. Richard.
Oh, I'm still there. Okay. I shifted positions. I thought maybe you lost my image when I clicked my microphone on. I think in general, it has merit to move back to the opportunity to apply that in the circumstances that they were talking about. In the specific long definition that was shown and they're suggesting, I am a little bit concerned about the way we present some of these clauses, so that it doesn't sound as if that for example, the part of the up to the discretion of the biologist or research scientist. I mean, ultimately, that's often what's happening anyway. It is a very subjective situation in many cases. So I'm just a little concerned how we put those types of verbiage into descriptions of horizon designations, or in fact anything in the taxonomy. The other thing that I note in there is the introduction of this concept of upland. And having gone through some experience with people in the ecologists here in Ontario, and recognizing that the use of this terminology of upland depends on where you are in various jurisdictions in Canada. I think we have to also be very careful of how we incorporate words like that or concepts like that in it, if we're not very clear on what that means. And I know there's a little bit of an explanation of what's meant by upland there, but how coherent is that? And I would suspect, if you look across the systems that are being employed provincially or nationally, not necessarily capturing what everybody would be satisfied with. And so do we set ourselves up for some kind of conflicts with interpretations of terminologies such as upland? Third component is the issue of the forest, humus form, the motor, and mol. Notionally, I have no problem with being able to go to that further level and describe that structures. But again, recognizing that the systems that are used from one province to the other are not necessarily the same. And so if we're not careful with that, again, we'll set ourselves up for some kind of potential confusions.
Yeah, and I think Richard, on the humus form thing, we'll get back to that. I think after discussing, I think more just what was proposed in terms of redefining LFH materials in the system, because you're right, the discussion around humus form classification goes, I think, well beyond and outside the scope of how we would define what LFH is in the Canadian system. And it really doesn't affect the way we would classify soil profiles or name soil horizons at this point. Even if we go to that, I see humus form classification as being complementary information that could be added to the system, but doesn't necessarily change, I don't think, anything that's in the system right now, at least, unless we're doing something drastic. But yeah. Okay, thank you, Richard. I'll go with Kevin Keys.
Yeah, hi. Very quickly, because I'm going to basically echo what others have said, but I think really that definition that was proposed just seems to be unnecessarily cumbersome to me. I mean, it should be just very generic. I mean, it's just recognizing organic layers and basically 3 broad classes of decomposition. Regardless of the substrate, regardless of the source of the organic. And so why are we listing all these possible kind of scenarios when really all we need to do is say this is what it is, and you apply it according to your, you know, your landscape unit, whatever that might be.
Yep. Okay. So essentially, yeah, echoing Richard's comments that the definition is much too comprehensive and can be simplified.
Yeah, and
Yeah.
by simplifying it, you make it less confusing.
Yeah.
And by default, it becomes easily applicable to every situation.
Yeah, and I have to say to agree with Richard too, and the point you made about things being the discretion of the pedologist, of the researcher, that was the first thought I had, Richard, is that that's always the case for everything, every decision a pedologist makes in the field, it's to their discretion. And so it doesn't need to be in a formal definition of any concept in the system, because we know that that's how it's applied.
Yeah, and I think most of us have already been applying LFH to non-forest ecosystems as needed. If we find it, we write it down.
All right, anything else, Kevin?
No, that's it. Thanks.
You're good. Okay, Paul Martin.
Thanks, guys. Can you hear me okay?
Yeah, you're good.
I more or less agree with everything everybody has said. At the end of the day, these things do exist. Some of the best examples I have are heavily organic sods, but mineral sods that I've run into, even in some grass-dominated, naturally reclaimed historic sites in northern Saskatchewan. Without a mechanism to capture these, like, I mean, these things exist and we need a mechanism to capture it, whether that's LFH or otherwise, there has to be a mechanism to capture it. They exist. Like Kevin, myself, I've just continued to call them out where they do exist. The only discrepancies I've run into, because of most of my work has been on the prairies or in the boreal, is in transitioning to the eastern slopes of the Rockies and getting into TEM classification and using the BC terrain classification scheme. And of course, BC has much thicker, more molder mull layers, and there's a lot of terminology in that. And it was a pretty steep learning curve, even for me, with lots of years of soils experience in the prairie. But you know, at which case most of our LFHs would fall under a single, very thin designation in their system. But there is a bit of a disconnect there. So I would just suggest that we need some way to capture these. LFH is familiar, but maybe let's just keep an eye on synergies with other systems across the country. My 2 cents. Thanks.
Thanks, Paul. Adam Gillespie.
Yeah, in the pictures that were shared, I think we ended up using the word thatch, and when I see that, I also see I see thatch, and which means something to deter people, certainly. But when I think of an LFH, I don't think of hatch as being, thatch as being part of that definition, but maybe it should. And I know we've been talking. Some of the previous commenters suggest that we should simplify that definition, and I completely agree. But I wonder if using the word thatch, and of course this is open for discussion, but to me I see thatch as being something that we would typically ignore, and if we pointed out that thatch could be something that would fit underneath that broad definition, that might help early adopters of soil characterization and students to understand that can also be included.
Okay. So Adam, you're suggesting that if a thatch layer is considered to be included in an LFH, then we have to be very direct in the terminology that we're putting into the manual, that a thatch is also included as part of LFH.
Yeah, that's where I'm going.
That's where you're going. Okay.
Yeah. Thanks.
Brian.
Yeah, that's a really good comment about the thatch, and I appreciate that the humus form designation is a whole other conversation, but it does kind of play into this conversation. Including LFH in the definition also limits all the possibilities, because yeah, what letter would you put for a thatch? It's, you know, then it becomes quite ambiguous. But and sure, it's up to the discretion of the pedologist, sure, but it kind of narrows, you know, this has to be an L, F, or an H, or a combination of both. So that my initial kind of why I raised my hand was the microbiotic crest on a brown or a dark brown chernozem. Very often, you know, there's bryophytes on the surface, and typically it's just ignored, which has always been a really hard, difficult thing. It should be recognized. And looking at the humus form, well, there is an S master horizon for bryophytes. Anyways, just adding to the conversation of, yeah, simplifying the definition, organic material, not necessarily an O horizon, but, you know, there could be a whole variation of letters, specifically especially in different provinces too.
Perfect, thanks. Yeah. So, and I was looking at the BC humiform classification, and yeah, they have quite a few other choices for I'm scared to call them horizons, but sure, horizons. Okay, let's go to Rongwei.
Hi, everybody. Yeah, I support some of the ideas to put the LFH. However, you know, I like to have we defer that is naturally occurring or not. If naturally occurring, yeah, that will be good for my personal opinion. And if human added on the top of the surface, that's not real. I do not support that of the ideas. So I just want to let the open discussion for this one.
Okay, thanks, Rongwei. Anything else?
No, thank you.
Okay, yeah, I was gonna put the Anthroposol people on the spot here after and talk to them, because I think that's certainly a consideration, is how anthropogenic organic materials are going to be incorporated. And I know that's kind of future work that has to come yet. So Konstantin, back to you again.
And yeah, that's just by coincidence. I'm in the anthroposolic soil group. So we never considered adding D horizons, which are disturbed man-made horizons made of man-made materials. We never considered adding them to any natural soil orders or subgroups. So even having a few centimeters of man-made straw layer would not imply application of D horizons to those soils, and definitely not application of anthroposol to such a layer, because it requires 30 centimeters. So if somebody make a soil of more than 30 centimeters of straw and store it, I mean, make a landscape of that, which potentially could happen on some straw solid, like storage facilities or farmyards, potentially, theoretically, then yes, that would be anthroposol, and that would be a DO horizon. Otherwise, LFH is the most, L, I guess, in this case, L horizon would be the most applicable. That's from anthroposol perspective anyhow. But I have few comments for records. So I really support the simplification of that definition that proposed in the article. what was few people already saying. The definition proposed is too complicated. It's not matching definitions of any other horizons. So phrases like to discretion of pedologists, that should be removed simply.
Mm-hmm.
Second one was to the comment, couple commenters before, bryophyte layer in grassland soils. Live vegetation is not soil. So live moss is not supposed to be a soil horizon. It's dead, decomposing material of mosses that become L, F, and H or O horizons, not the live crust of bryophytes or grasses or other veg. Then to the comment of upland, few people before, it was about definition, particularly about Ontario, what is upland, how we apply that terminology. It could be transferred, or it's already partially transferred there, into imperfect or drier drainage classes, and that would eliminate need to use upland or wetland. It's just upland. I mean, it is just well drained, generally speaking, well drained soils, and that's enough. But I have a big one that is not covered in the article, and I'm kind of surprised about that, and this is turning point essentially. Organic soil order has Folic that are by definition made of L, F, and H horizons, and I don't think it is addressed in the article as like it has to be changed somewhere somehow. Or is it addressed? They are upland soils, but it is the whole great group. Yeah, that's just to bring that to discussion. I don't have answer, I just pointing it. Thank you, that's all I have.
Okay, thank you, Konstantin. I'm just writing something down here. Yeah, and I think that's the reason why we use LFH in Folic is because it's to respect the drainage or moisture regime of the site. And I know we have someone on the call that's an expert, more than I am in Folic, but let's go to Jordan's comments, please.
Can you hear me?
Yes, yeah, we can hear you, Jordan.
Okay, sorry. Just more of a question rather than a comment. In one of the definitions, I noticed they included chaff as possibly being an LFH horizon. But what about like short-term lived chaff in like a conventional tillage situation? So like you have a canola field, they've spat out a bunch of chaff on the tail end. Do you then call that an LFH, even though it's a temporary thing?
I mean, I think it would qualify as an L. It would be litter. In most cases, that would get eventually incorporated, I think, into some of it, at least, into the mineral. I think it's really for me at least, it's one of those things. It's as a pedologist, you describe what you see in the field when you're in the field. And so if I open up a soil pit and there's an inch of material sitting on the surface, then I would probably describe that inch of material sitting on the surface as something. And include it in my description. And if I went the day after that material was tilled in for some reason, and it wasn't sitting there as a layer at the surface, well, then it's incorporated into the mineral layer, and it's just part of an AP most likely. So yeah, I think you just describe as you see in the field. And so if you happen to be there the day after they've applied, or the day after they've spread that residue across the field, well, then it's there. I don't think that we can put a temporal aspect on the descriptions of what we're doing in the field. It's what you see when you're sitting in the soil pit.
Okay,
That's
Just
just
wanted
my,
to
that's my bias. Like, I mean, that's
hear
my,
other people's thoughts on it.
yeah. Richard, go ahead.
My comment was exactly along that line. How do you handle that sort of circumstance where you might be in an agricultural setting where maybe in a rotation system, you might have a period of time where there's been no tillage, then suddenly, especially here in Ontario, they might come along and decide, well, we're going to plow this year. And what does it mean then to have that description at a certain point in time when it could be a transient aspect of that particular soil system? I agree with you that it's, I mean, ultimately one has to describe what they see at the moment, but in terms of a broader interpretive perspective of that, how does one do it? It's not the same as necessarily having a relatively continuous LFH on the soil surface. When you've got this occasional mixing and incorporating, it has different implications in the dynamics of the soil system.
I guess I'll go through the comments, but if yeah, if anyone has any comments on this, you know, this question of temporal aspects, I'd be happy to hear. I'm just trying to think of scenarios. I mean, someone could go describe a soil profile, and then a week later, someone's gone and put a pipeline through that forest, and that soil is different, and someone else could describe it, and it will be different. I mean, I'm not sure that we can predict or deal necessarily too much with temporal aspects. I suppose you could, in your notes, indicate that, you know, that it's some aspects of the profile might be temporal. I'm not sure. Kevin, go ahead, please.
Yeah, just on that note, the same consideration already happens in a forest setting. I mean, if you went out in October to do a profile description, you're dealing with 6 more inches of leaf litter than you would have had if you were there in June. And so that type of scenario, I think, is just part of the, you know, part of the system, so to speak. And it doesn't change really your interpretation of what you have. If, you know, if it's going from an L to an AH in that type of system, for instance, the tolerant hardwoods or something, you would recognize that is going to be pulses of that type of litter, same as you would have in an agricultural setting. So.
Thanks, Kevin. That's a good point. Paul Martin.
Yeah, I'd kind of like to build on what folks have been saying and go back to my previous point that elimination of the usage of LFH in non-forested scenarios, in my opinion, was a bit short-sighted in the 3rd edition. Because again, we come to these situations where we have predominantly organic horizons that exist at observable depth in the landscape, regardless of the reason for it. Having read the article prior to this meeting, my understanding is it's a big proponent, like a big concept of the argument is the buildup of residues in zero-till applications in Western Canada, which may be a primary driver for this. But again, regardless of the nature of the input, if the inputs are building up to a point where you have 1, 2, or all 3 of the LFH components in an observable layer, we need to have an ability to capture that data. It has relevance. It has relevance from a carbon sequestration standpoint. It has relevance from a nutrient cycling standpoint. I know these things exist because I've dug plenty of native range and tame pasture, native pasture. I've dug undisturbed Chernozemic grasslands when you can find them. I mean, these layers exist, and where you have greater than 17% organic matter in some form or another, and you need to categorize it. My argument right now, having listened to everything, is LFH, and we can argue whether it's appropriately used or not, is the most familiar concept to our body politic, and captures the elements in play. lends itself to synergies with other paradigms, and makes the most sense to me.
Thanks, Paul. We'll go to Paul Sanborn.
Yeah, so getting back to the question of timing and the degree of transience of a particular feature, I basically would say call it as you see it. And if a particular feature is only there for a year, or only there for 10 years, or only there for 50 years, well, when you're there, you describe what you see, and it's important to build up our knowledge of the range of variation of soil characteristics, and not sort of censor our observations because we think it might be something that's only there for a short period of time. And if we think of grasslands, even what we call natural grasslands in the British Columbia interior, and Brian can chime in here, we're dealing with systems that have been highly altered by 100+ years of grazing, major changes to the fire regime, and we don't really have a good sense of what the pre-European fire regimes might have been in our grasslands. It's quite likely that the Aboriginal inhabitants did manage fire. So all of these things will impinge on the thickness and characteristics of surface organic horizons. And, if a pedologist 100 years ago might very well have seen something rather different in our interior grasslands than we would today. So, build up our observations and call it as you see it.
Thanks, Paul. We got two more, Adam and then Constantine.
Sure. I'm thinking about I'm not as worried about the temporal aspect, and the reason for that is because I think that these horizons are going to take a while to develop, and so if you see them, I think that they've been part of that particular soil forming process, whether or not it's anthropogenic or any of those sorts of things. I think it's something that is developing. If somebody comes along and tills it or burns it or digs it, that's not something you can't see into the future. But I think that having some kind of a layer like this in a soil is indicative of at least an integration of time over the medium term. So I'm quite comfortable with calling it when you see it, because I think it's definitely something that would have developed. But one of the things that I was a little worried about, and I just dug out my book, was like, what if we overestimate it? What if it's, what if we make a mistake? And I think it's worthwhile remembering that we do consider these layers to be above the reference point. So these are minus. And so if we are trying to do mineral soil carbon assessments, and we screw up our LFH depth, it's we've only screwed up the LFH estimate. We haven't made a mistake on the whole storage profile. So again, I support this. Done.
Thanks, Adam. Constantine.
I think I'm beating that horse now, but yes, I support. I would say that we should describe LFH in agricultural ecosystems, despite the temporary nature of it. And we do have, I totally bring Kevin's case. Yeah, L horizon in in deciduous forests is totally dynamic, depends on the season, and despite the fact, yeah, we describe what we see. Yeah, so I support description of straw, even if it is for a year or for a season. It's basically the same idea as foliage layer, which is the L horizon by definition. That's it.
Thanks, Constantine. Yeah, I just point out, I mean, what we're really talking about, I guess, is just modifying the first part of the definition of L, F, and H. The L, F, and H all have their individual definitions in the current system. It's the kind of the first definition that groups all of those things together. And it's interesting that the LFH points to specific materials like leaves, twigs, and woody materials with a minor component of mosses, which is odd because when we're talking about folisols, I mean, there's a combination. You can have a higher component of mosses, but anyways, but then when you look to the LFH individual definitions, there's no reference at all to the types of materials. It's just organic material, and it's at different levels of decomposition. And so I suppose I question the need to define at all the types of materials that are seen in LFH, in that collective definition of LFH. Maybe it should just be organic materials, end of story. It doesn't matter what the origin of that organic material is. The only exception would be the O horizons, right? The O horizons, because those are wetland organics versus upland organics. And I have some questions for some of the people on the call as well, to follow up on that in a few minutes. But first we'll go to Graham Spires, please.
I say, as I'm listening to the discussion here with a fair bit of interest, actually, I'm thinking back well into last century when I first came to Canada and was closeted as a teaching assistant with Steve Folic and Marv Dudas on various occasions, and going out looking at soils in the Edmonton Basin and beyond. Being a dumb farmer from New Zealand, I would describe what I saw, which was LFH over AH on all the Chernozemic and, shall we say, related soils. And Steve would wrap me over the knuckles and say, you can't put LFH on the Chernozems. And I said, why not? They're there. He said, well, the expert committee has decided. And that is the problem. This is the new expert committee, and it has to make a new decision. And I think the old one made a mistake.
Thanks, Graham. Tony?
Yeah, good morning. I was interested in this whole conversation, and I certainly support the addition of LFH under agricultural situations. I know it came in with zero-till practices, and that was where we started getting this thatch layer, and people were saying, well, we should be able to describe them, and so I support that. So I think we want, in the definition, I kind of initially like the broad definition, because people use this taxonomy as a dictionary when they're in the field. I mean, they're sort of going, what am I looking at, and what sort of scenarios can be covered? So I think we still want to possibly include some examples, such as thatch, residue cover, along with the woody residue, etc., mosses. So I still feel we want to be inclusive in that respect. The other aspect I think we want to consider is when we're adding the LFH definitions to the subgroups, are we going to just blanketly say that they occur on all scenarios? So in the brown soil zone, similar to the black, in the old book, we had scenarios where the LFH was included with the black and dark gray Chernozems, but it was excluded from the brown and dark brown. Those other things we might want to consider, and how broad we include the LFH definition or inclusion within the descriptions. Thank you.
Thanks, Tony. Yeah, it's interesting because some of the example photos that are in the paper are from brown and dark brown Chernozems, and they're showing examples of LFH material. So it's interesting, but certainly there would probably be lesser prevalence in some of those drier systems.
Yeah, there are scenarios, I guess, but yeah, I agree, Daniel.
Yeah, interesting.
Yeah, I would say brown zone also has them back in other countries and other prairies landscapes.
How thick? Sorry, I'm not sure.
5-7 centimeters, something like that. That's back to Russia. Yeah, in brown zone. Yeah, it's we call it step felt, which is one of the pictures on the in the article, shows very good example that I can say, yeah, it could be taken in Russia all days. Yeah.
Jim for a comment, and then Kevin, and I think we're gonna have to expedite onto one more item before we move over to the organic cryosols.
Okay, I'll be quick, Dan. I'm in agreement pretty much with the discussion we've had here so far. And if you go back to it, an LFH layer way back in the day used to be referred to just very simply as a litter layer. This is a litter of plant material. It was not specific to the origin of that material. And I think if we basically go back to that, in other words, we don't try and split hairs as to what or where the material comes from. Essentially, you've got it covered. I think we have to, if we're going to use terms like upland, essentially upland being as opposed to lowland or wet soils, I think we have to define those two terms if we're going to use them. That's really all I had to say. Thanks.
Thanks, Jim. And Kevin?
Yeah, I'll be very quick too. I agree with that. I mean, what the litter source or the original organic source is just going to depend on the ecosystem. So why are we trying to, so narrowly define it? We just call it organic input from whatever the ecosystem is, and that's going to dictate what it is, how long it lasts for, and everything else. So, and then the other thing is the diagrams. One way to approach it is the opposite, is you don't even bother putting the LFH on any of the diagrams because it doesn't define anything for anybody within the system. It's either there or it isn't, and if it is, fine, you describe it, but you don't need to see a profile picture of it in the opening of each chapter.
Yeah, that's a good point, Kevin. The only place where LFH is going to be diagnostic and is critical is for the folisols, and other than that,
yeah, and maybe that's all. That's the only place it needs to be.
And maybe for the organic cryosols, but we'll get to that next. Okay, so I just wanted to let's see here. So going back to one of the recommendations from the paper was, what about humiform classification? And so one of the things I'm wondering, we can't get into it in detail, but in the Google Drive where we've got all of the materials, Brandon has added another subfolder for humiform classification, where he's included a few different iterations of the humiform or the taxonomic classification of humus forms for British Columbia. And so I think it's important to note that there are these comprehensive systems that do exist. There's also a forest humus form classification for Ontario and a chart for classifying those, and that comes from our ecologist colleagues at the MNR. And so I guess my question is do we feel as a working group, do we feel that we should maybe do some additional work, which is beyond the scope of what we're looking at or trying to address today, which is just changing the definition of LFH essentially. Do we feel that we need to potentially put together a working group or something along the lines of what we've done for the anthroposols and for the redoxymorphic features that would look more closely at the potential for integrating some form of humus form classification that could be complementary or kind of slide into the Canadian system of classification for those that are looking to provide, I suppose, additional context into defining LFH materials when they're doing their classifications in the field. Let's see. I'll just leave that one open, but I know Brandon, do you have a comment on that? I know that because you did a lot of your work in BC for your grad work, so.
Yeah, I guess what I was thinking is not so much the humus form taxonomic system, but perhaps using some of the lowercase suffixes to add additional precision to how we define the L, F, and H. I think that might be useful.
Right, essentially like additional horizon modifiers to further refine the descriptions in the field of what you're seeing.
Yeah.
I see Kevin's got a hand up.
Yeah, very quickly. I mean, just to show it's not just in BC. We used the system that Green and others described in '93 for our ecosystem classification work. We found it very helpful. So, you would have, instead of having just an F horizon, you would have an FM, for instance, or an FA. And same with the humiform horizon. It could be an HR and HH. We found that helpful. And it wasn't, it wasn't onerous or anything to apply. And it did help us with our analysis. So I would support that, at least a basic level of integrating some suffixes for those major horizons.
Thanks, Kevin. Margaret?
Yeah, I would also support some suffixes for the horizons. And also in the new ones, I wasn't here for the first part of this meeting, so I didn't hear the whole for the LFH for the agricultural areas or the grassland areas. But I would think that you'd want that there as well, because especially if people are recording information in the field, sometimes they don't even record necessarily what the land use is. And it'd be nice to know if you're in forest or in agricultural area or in a grassland area. And having the suffixes would give a lot of additional information, I think. So I'd be in support of using better, clearer descriptors of the LFH horizons.
Okay, perfect. Thanks, Margaret. Graham?
I'd support putting more detail in on the humiform as well, because the humiform is possibly the most critical part of the soil from a management or active biological area. And having the descriptors, I've tried to encourage people working with me always to have a really good look at and use the BC or the Ontario humiform stuff. It's I think it's a weakness in the Canadian system. And I even made the mistake last week of picking up the latest version of soil taxonomy, and I don't want to see a 1,000-page document, but I think there is perhaps room to get a bit more meat into the descriptive side for the Canadian classification book that's going to come out as a result of this eventually, or else you're shortchanging the next generation.
All right. The last question I was going to ask, and this is to the more experienced pedologists on the call. I was trying to find some information about when the Canadian system diverged from US taxonomy, whereas US just went with the O horizons, regardless of whether it's an upland organic or a wetland organic. OI, OE, OA, end of story. And the Canadian system left the O horizons with the wetland organics and introduced the LFH horizon for upland organics. And I'm just wondering if there's anyone that I've gone through all those National Soil Survey Committee meetings from 1945 until today, or till 1998, and there's nothing in there that really describes the transition. There's actually very little that describes the transition even to LFH. It just kind of all of a sudden appears. So I'm not sure if there's anyone on the call that recalls any discussions earlier in their careers about this kind of stuff, but I'd be interested in getting some more details. Okay, so I'm not sure how to move ahead with this, but I think the thought then maybe is, from what I've heard for a couple of these things, is that yes, we should alter the diagrams. We're not sure how yet. We either remove LFHs or add LFHs. Same thing with the subgroup descriptions. In terms of the definition of the LFH, what I'm hearing is that we feel that this definition is much too lengthy and detailed, and we need to really simplify it. And I don't think that we're going to get to a simplified definition of LFH today. So what I'm thinking of doing then is tabling this for a follow-up meeting. Maybe take a few minutes at the start of one of our next meetings to revisit a definition of LFH that we can look at. And maybe what I'll do is, based on the comments that I've seen here, is come up with a modified definition from what that was in the article and circulate that, and then we can decide whether or not we're happy with that, or we can tweak it. Does that appease everyone for today? Or was everybody really looking for like the first final decision on a change to the taxonomic system, and they're heartbroken that we haven't come up with it? No, okay, we're good. Okay, so what we're going to do then is we're going to shift over to Paul Sanborn, who is going to walk us through his proposal for folic cryosols.
I need to share my screen, and this is not something I do very often. So if it bombs, our backup plan here is Dan's got my slides and he'll end up having to change them manually for me. So here we go. Does everybody see that?
Yeah, you're good to go, Paul. Perfect. Thank you.
Okay. So first of all, I want to acknowledge my three co-authors, one of whom is on the call, Scott Smith. This was I think a stellar example of federal provincial academia cooperation in action, something which I think the soils community can be proud of. The other thing to note here is that 50% of the authors are now retired, and that I think is something of a reflection on the demography of podology in this country. But they're still in there active. So anyhow, the origins of this work, this is based on field work that we did in 2012 in late August along the Alaska Highway in northeastern British Columbia. And I guess the genesis of this, there's sort of two things. For much of the first decade of the 21st century, I was doing field work in Yukon and regularly drove the Alaska Highway every summer to get to my field work in points north of Whitehorse. And I usually drove the stretch between Fort Nelson and Whitehorse in one day, which is a bit of a death march. It's about 1,000 kilometers. There was all these cool looking things that I drove past, which I never had a chance to stop and look at. So it was always in the back of my mind that there were sites that looked really interesting that I wanted to check out, but I just never had the time. And then Martin Geertsma, my Ministry of Forest colleague, who is very interested in permafrost as it affects slope stability, had actually been installing soil temperature monitoring stations and small weather stations at various points in northern BC, and had actually been monitoring permafrost occurrence and its temperature regime at sites along the Alaska Highway, which, unknown to me, I was driving by fairly frequently. So we got it all together and had an expedition of the four of us in late August 2012, targeting sites in the Toad River area of along the Alaska Highway, west of about a couple hundred kilometers west of Fort Nelson. Now, just to set the stage a bit here in terms of permafrost distribution, this is a bit dated now, 1995, but it's still the official map of permafrost distribution in Canada. And I've excerpted the area for southern Yukon and northern British Columbia. The area that is circled in red there is the area where we did our field work. And at this kind of national scale, these categories are really quite aggregated. It's within the zone referred to as sporadic discontinuous permafrost, 10 to 50% of the landscape, which is a pretty large category. So what this sort of national picture tends to miss is just the very fine-grained detail that affects the distribution of permafrost in the landscape, particularly as you go south towards the sort of more marginal occurrences. And so one of my co-authors, Chuck Bulmer, at the time in the Ministry of Forests in Vernon, very handy with GIS, used this modeling tool to show the distribution of solar radiation in this landscape. And it was influenced by the underlying digital elevation model. And so really what this shows us is that there's very strong aspect control of solar radiation, and basically the north and northeast facing slopes are going to be pretty cool. And this isn't the only thing that affects the distribution of permafrost. For example, thickness of winter snow cover is another influence. And also in some of the larger valleys, you tend to get fairly persistent inversions, which will maintain cool temperatures more than you might expect just based on elevation and aspect. But what this shows us, the purple and blue areas indicate that we got lots of cool spots, and these should be prime areas for persistence of permafrost at this latitude. So just in extreme northern British Columbia. So on this map, we had two areas where we did our field work. One is east of Toad River, and the other is just a bit to the west. So these are sites that are in total about 50 kilometers apart. And I'm not going to go over the ground that's covered in the paper, looking at sort of the historical development of terminology, because you all did your homework and read it. I'm going to show you things that were mostly not in the paper, just to kind of enrich your impression of what these soils actually look like. So this is the example that we put in the paper. You can see a landscape view of this site. It's a very open black spruce forest with an understory dominated by shrubs like willow, and at ground level, a very thick moss layer. And this would be and pardon the word, an upland moss. It's probably Hylocomium, but I'm not a moss taxonomist, but that's what it looks like to me. And I'd driven by this site several times, and it always struck me that these look very different from the other forests. And what I don't show in this composite is what it looked like on the other side of the valley, which is very different. It's a mixture of pine and aspen and Cryosols underneath. So when we finally got a chance to look at this area in 2012, I've got a picture of the soil profile here. We were there at the very end of August, and we hit permafrost or frozen ground really almost as soon as it got out of the organic layers. So really, there was almost, the active layer did not include really hardly any of the mineral soil. Another site just a little bit farther up the slope, pretty similar looking. The permafrost table is just barely into the mineral soil, even at the end of the summer. You can see lots of organic matter, inclusions of wood, buried horizons, and some of that buried wood is charred. And so we speculated that on a site like this, you probably got considerable instability after forest fires, and that would result in mass movements that would incorporate woody material at sometimes considerable depth. And then the final site that I'll show here, this was west of Toad River. This is not nearly as steep. This is actually an alluvial fan with fairly low slopes, less than 10%. Again, thick moss layer dominated with vegetation dominated by black spruce and tamarack and willow. Again, at the end of the summer, the seasonal thawing has barely penetrated into the mineral soil. So when you try and classify these according to the current version of the system, they don't really fit very well. These would definitely be organic cryosols, but the organic horizons are not O horizons. They're LFs and H. So one of the spin-offs from this work was the suggestion that we could tweak the classification of organic cryosols a bit to give some kind of recognition to this particular type of organic cryosol. And really the pitch that we're making here is that although our field work really was restricted to these sites along the Alaska Highway, which is basically the only accessible area, we are pretty confident that if you look at the climate controls, that there's bound to be lots of terrain like this and lots of soils like this. And I would also mention that some work that was published more than 40 years ago as a spin-off from the biophysical inventory in Banff and Jasper National Park. It indicated, it talked about the distribution of permafrost and cryosols in the front ranges of the Rockies in Western Alberta, in settings very similar to what we had in Northern British Columbia. The difference is the soils don't have quite as thick organic horizons, but in every other respect, they look pretty similar. So we're confident this isn't just a little local fluke. This is something that is pretty common throughout the sort of eastern fringes of the Cordillera. So I'm going to look a little bit here about proposed wording. So the original manuscript had included a table which gave our proposal for the wording that could go into the revised classification manual. And then on the suggestion of a reviewer, I actually believe it was the editor, Dan, you can refresh my memory here. The proposed wording was simplified and shortened a little bit. That's what is in the accepted version of the article, which you have all looked at. And I guess there's some loose ends here, and at some point my co-author Scott can feel free to jump in. And I just want, before we have any further discussion, I just want to add 3 points here, which I have sort of detached from the proposal, but I just want to mention them as potential discussion points, which could be looked at separately from this proposal, but they're sort of in parallel to it. So I don't want to derail the main proposal, but just sort of plant some seeds here. So the first one is that for situations where we don't quite make it with thick enough horizons to make these organic cryosols, it might be nice to have Folic subgroups that could be used in the turbic and static cryosols, where you've got 15 to 40 centimeters of organic material, which is not O-horizon material. And that would probably cover off those situations in the Rockies farther south, as was noted in the paper for the Banff and Jasper work. Another suggestion, which Scott made, again, this is sort of in hindsight, maybe we should consider having pteric subgroups in the organic cryosols, because some of the examples that we saw have got a mineral contact within 100 centimeters of the surface, and maybe that should be recognized. And if we did that, this comment here, item number 3, would be kind of redundant. That would simplify it. And then the final thing, I just want to remind you of a really nice presentation that Angela Bedard-Hahn gave a couple of years ago at our annual meeting, which was to point out that there's many places in Canada where we find evidence of slope aggradation, which creates what are essentially cumulic profiles. And yet our classification system only recognizes in the regosols. And I thought of mentioning this just because the examples that we saw in this very dynamic mountain environment certainly show evidence of aggradation. And maybe we might want to consider applying the cumulic term. Now, the caution is that we don't want to have a million subgroups, and we do have to think about the including the subgroups that are distinctive enough and abundant enough that they're worth recognizing officially. And I know Scott has done some arithmetic here to look at the numbers of subgroups in some of our orders, and there's actually a surprising amount of variation. So just to flip back up here, the top half of this slide, this is the version of the this is the accepted article version, which lists a potential wording for the revised classification. And Scott, if you want to jump in at this point and add to whatever I've said, please feel free.
Yeah, okay, thanks, thanks, Paul. Yeah, just a question on that first point. They are composed dominantly of folic material in the control section below a depth of 40 centimeters. It's a different statement than what we had, and I find that statement a little bit confusing. I would read it that there's a requirement for folic material at depth in the soil profile, and that's not really what we intended. So I just wonder if why that change was made and what was the intent on that statement. Nobody knows. Okay, I just think we should we need to revisit that. I just the way it's stated. My interpretation is that that actually is not what we intended when we made this proposal. It's a fine point, perhaps, but it's composed dominantly of folic material. You know, to an accumulated thickness of more than 40 centimeters. That's the intent, rather than occurring in the profile at some depth. So that's a minor point, but we need to clean that up, I think, when we were to, if we were to move this forward into the revised taxonomy.
Okay, well, I'll turn this back to the chair of the meeting and take it from there.
Thanks, Paul. Sorry. Let's see here. You're probably right, Paul. I probably did review this one, or maybe it was the editor. I can't remember, but
I think you were. Yeah, I'm sorry. Gonna have to out you.
No, that's fine. I'll go through the revisions, and I'll try to figure out why that change was made.
And, you know, frankly, when we were reviewing that, I just went along with your suggestion because at the time it didn't seem like a big deal, and I'm not quite the classification maven that Scott is, so I just went with the flow there.
Yeah, so we can hash out the details of that of the definition itself, because I'm not 100% sure as well. I'll have to go back to the different versions with all the reviewer comments. So let's go. Sorry, I wasn't looking at my screens there. Let's go with Paul Martin has a comment.
This may end up being more of a question and show my ignorance in the matter, having seen deep heliconium mats like this, but not having done as much work in the permafrost. There's a question in my mind, knowing that this is considered an upland position, but also coming from the Hudson Bay lowlands, where there's a great deal of permafrost. I'm curious about the assumption that these are, you know, these quote unquote uplands are, you know, imperfectly to well drained. I'm going to lead with that, and wondering in my mind whether or not applying Folisol designations to feather moss, deep accumulations of feather mosses, is appropriate, as opposed to OF, OM, and OH designations. Just because I admit here I've probably been using the system wrong, because my understanding of Folisols was that they were essentially deep accumulations of litter material that have undergone varying amounts of decomposition. And I have in the past equated deep feather moss mats and their degree of decomposition as being similar in nature and depth to sphagnum dominated, organic systems. And maybe this lends itself back to this whole LFH designation. If we're having if we're going to have trouble, even me, figuring out which materials we choose to classify into one or the other, perhaps there's an absolute depth where you switch. Just throwing that out there. But please, to the fellows that made the presentation and know more about this with me, slap me around a little bit here and help me understand what I have been doing wrong.
Paul, do you have a response for Paul's question about the specifically, I guess, the feather moss and the thickness of feather moss? Why we're using LFH as opposed to OF or OM or OH based on the degree of composition of those more upland vegetation types?
Yeah, well, it really had a lot to do with the landscape setting. I mean, these are 30%, 40% slopes.
Yeah.
I just had a lot of trouble putting those in the same category as a peat bog down in the valley bottom. It seemed to me that it didn't make sense to lump everything together. I mean, that sounds kind of simple-minded, but really that was just the basis for it. This is a pretty obvious ecological distinction. The greater degree of geomorphic activity in these settings is also ecologically meaningful, and it just seemed to be worth capturing that. Nothing more to it than that, really.
Yeah. Okay. Thanks, Paul. Tony?
Yes, I was just I was looking at the definition of folic horizons or folic layers it's in the present classification manual. And it goes through and says, that it's accumulation of leaves, twigs, and woody materials with or without minor component of mosses. So I think if we're going to include these folic organic cryosols, then I think we need to modify the folic layers definition to include the fact that we've got non-sphagnum-like mosses that occur in accumulation to this depth. And that's why they're LFH and not OMs, if that might help.
Sure, Tony. So you're pointing to the definition of LFH on page 18?
Yeah.
Yeah, okay. Yeah, and it's funny actually, we put the two topics on the same day, but they are somewhat, interestingly enough, somewhat related. And I think that goes, to the comment of, do we actually need to specify the types of materials that make up LFH horizons or not? Anyways, let's move on to Rongwei.
Hi, it is a very beautiful profile. And my question is what types or what kind of parent material for the mineral part of the soil profile?
Paul, do you have an answer?
Sorry, I didn't quite hear the question.
Oh, sorry. Yeah, sorry. Yeah. What kind of parent material it is in the mineral part, not
Okay.
on the,
Okay, so at these examples, so on the steeper slopes, I would probably just call it colluvium, although it's likely it's till that has also been modified by slope movements. And then on the alluvial fan, that would be a fluvial deposit, although very poorly sorted. It's probably built up a combination of overbank deposits and mudflow deposits, so kind of muddy material.
Okay, so from that profile, look like a very thin of the white strip. Is that the sandier soil or clay soil, something like that?
Okay, so this example for example, was on fluvial fan, less than 10%
Okay.
slope. And you know, you're looking at color differentiation there with lots of, due to the presence of little buried AH horizons. And we didn't separate all of them. There's lots of little stringers that are a centimeter or two thick. So this would be kind of, if I saw this on a floodplain and it wasn't frozen, it would be a cumulic regosol. These examples here are tills and colluvium, kind of all jumbled up together. But you can see there's chunks of wood included there as well as a legacy of past slope movements.
Yeah. Okay, thank you.
Richard.
Yeah, I'd like to follow up a little bit on what Paul and then Tony were talking about. And yeah, I was reflecting on this issue of that the LFH does allow with or without minor components of mosses, and then we go to it's mainly from mosses, and so I'm thinking, are we comfortable in the application of these terms mosses and rushes and woody material vis-a-vis our understanding of the ecology that generates them? In some circumstances might be cooler, and so we're seeing that you're getting the mosses developing, whereas in other, often where the knee jerk is that, well, these types of mosses that we're normally thinking of and using to assign the O is we're thinking to a wetland scenario. So do we effectively understand the ecology, temperature, moisture regime, and its consequence on what type of moss or other vegetations? And so is our O's and our L's based on what we're seeing in terms of a material, or is it somehow linking back to what we're thinking that material represents in terms of the ecological conditions that they're developing in? That maybe a just disjointed thought, but I'm seeing that whole issue that we're yes, we interpret, we describe what we're seeing, and then there's the interpretation side. And sometimes are we effectively able to link that what we're seeing to an interpretation, which here we're trying to split between really what we would normally associate with organic soils being associated with more wetland conditions versus that which is upland.
Go ahead, Paul.
Yeah, so just as a bit of, I guess, an example of some of the influences on my thinking. So a couple of years before we did this trip to the Northern Rockies, I had done some field work on Graham Island in Haida Gwaii. Very different kind of landscape and a wetter climate. It was basically a flat glacial outwash plain with old beach ridges superimposed on it, created by different sea level fluctuations. And there, the whole landscape was kind of teetering on the edge of wanting to become a bog. And even little things like whether you were on the north side or the south side of a large cedar tree would be, it was such a sensitive system that on the north side, the surface mosses were all these the south side, these mosses were all feather mosses, similar to the ones in that we saw at Toad River. And then as soon as you got on the shady side of the tree, there was maybe a square meter patch taken over by sphagnum. and so these two different moss types were intermingled in an exquisitely detailed pattern dictated by what might be otherwise very minor differences in microclimate and moisture regime. So that example was kind of in the back of my mind when I was looking at these sites, that the mosses tell you quite a bit about their environment. And I had many conversations as well with ecologists in the Forest Service as over the years when I was doing field work and learning from their observational wisdom. So that's basically, how my thinking was influenced.
Thanks, Paul. Jim.
Yeah, I've got a sort of bunch of disjointed thoughts here that I'd like to add to the conversation. I guess the first one being, okay, the addition of a folic subgroup to the organic cryosols. To me, intuitively, that makes sense because, of course, we have folic organic soils as well. So the fact that you've actually got a frozen version of that makes sense to me. So I'm in support of that. We also talked a little bit about the subgroups and adding a taric group. Again, since there's a non-frozen version of it, I'd be in support of that as well. The one thing that I'm a little curious about here, in fact, the photo here shows it quite well, is that, okay, you're in your LFH layer above where the permafrost table is, but okay, I'm no expert by any stretch of the imagination, but I'm looking at that and saying, that feather moss is alive. So is that material now soil, or is it now vegetation growing on the soil? Now it's a bit of a splitting hairs a little bit, but essentially by the primary definition of soil, if the material is growing, it's not soil. It can, like soil can support materials to grow, but so, because I know there's a lot of it there, but is that, I asked the question, is that because it's growing, it's not technically soil, is it? Or now are we including that? And if we do that, we have to, by extension, then say, okay, well, there's the trees there too, so they're part of the soil as well.
Well, I think
taking it to the ridiculous, of course, but
I might be wrong, but I think just the green part at the top of the moss is what's actually living, and the rest of it is all dead material. And so that's why the brown material there is all considered dead material as part of the soil. Just the green tops of the mosses are what's the actual living part of the organism.
okay, like I said, I'm no expert. I just wanted to make that clear. And
If I could respond to that just briefly, Jim. So
yeah, go ahead, Paul. Yeah.
I mean, that's a legitimate question, and I thank you for asking it, because I've wrestled with this sometimes, figuring out which part of the moss is living. This has come up in sampling that I've done in other contexts. We called this as being F because it's, if you use the same sort of qualitative tests that we do to distinguish things like OM and OH from OF in terms of rubbed fiber, that stuff, that reddish brown material that we've designated as F, if you rub it between your fingers, it disintegrates, and the uppermost green portions don't. And so that was really our basis for calling it that way.
Okay,
but that's a legitimate question, so thank you.
No worries. Okay, thank you. That clarifies that, at least for me. And sort of the last thing is your comment on the cumulative layers, which you get, of course, on the very steep slopes. You can get in the mountains there. One of the things we've batted around in our own stuff with the leptosols is the fact of using, instead of multiplying the number of subgroups by introducing a cumulative term into the into all the definitions. One of the things we talked about is using without going down the rabbit hole too far, a leptic qualifying term. Okay, so we can talk about that when we get to the leptosols, but in this case, we might want to give consideration to something like a cumulative qualifying term here, and it might work. Now that was tried years ago and they discarded it way back in the 70s. But it may be something worth considering. I think it's worth considering, at least for a number of terms, and it might fit as well for the cumulative qualifier, if you want to call it that, or qualifying term.
So thanks, Jim, and actually this is rather parallel to a conversation that I had with Scott earlier in the week on this very point. And one of the things that we run into here is it's nice to have a classification system which recognizes, which gives a name to things that you can see out there. But if we were to add a lot more subgroup categories to our system, we're going to end up with a monster that's as fat and heavy as soil taxonomy. And I think we might not want to go there. And this is where the world reference base is maybe a little bit more efficient, because it's got these modifier terms which can be applied in as many as you want to a particular reference group. And that kind of gets you out of this dilemma. But that would be a very radical reshaping of our system, and I don't want to go there right now.
No, I'm in agreement with that. It's a
Yeah.
deep rabbit hole. So
Yeah.
but anyway. Thanks.
But I'll also add on top of that that I was looking at there are cumulic subgroups in the organic order as well. So interesting that they're there in the organic order as well, not just the Cryosols, but they don't appear really anywhere else. So let's go to Paul Martin. Maybe we lost him. We'll go to Constantine. Oh, there
Are
he
you
is.
there?
Yeah.
Is it okay?
Yeah, we're good. We can hear you now.
Okay, sorry about that, folks. First of all, thank you for the explanations and the discussion. And Paul, I wholeheartedly agree with you that these on those slopes and the corollary, there's corollaries in my mind from my experience in the Shield and certainly in thermokarst topography. Pulses and such where those elevated positions and anything with slope end up becoming default upland positions in those ecosystems. But I wonder, when I've been listening to all this, I still wonder if perhaps this is an artifact of an assumption we've made that O should only apply to mosses deposited in wetland positions. And perhaps our understanding of how O can accumulate in the landscapes with respect to permafrost dominated regions is misunderstood. And that in the case of these mosses, it may be more appropriate for the moss layers themselves to be O, but certainly with the diagram in front of me where you have litter layers that are in various decomposition phases underneath, to me, those are folic materials. And there's a corollary to that too in the thermokarst regions, and that I've been up on a lot of pulses where all you got left is reindeer lichen and the needle mats, and you're not getting the moss input anymore. And those become predominantly folic inputs to those layers. So I'm wondering if our understanding and application of the two different paradigms is correct in this particular case.
Yeah, it's good. It's a good point, Paul. And actually, I was looking at today for the LFH presentation that I slid together earlier. I was looking at the definitions of the great groups for the histosols in the American system, and I find it interesting how they separate. They don't talk about. There's no differentiation between their organic materials in the American system, right? There's LFH they don't use. It's just O, and then they just have O, A, E, and I. And then the other interesting thing is that when they separate the folisols out from the wetland organic soils, that's the first separation at the great group level, and it's based on the level or the amount of time that soil spends under saturation in a given year. And that's how they separate it out from everything else. So it has nothing to do with the composition or the botanical origin of the materials. It has everything to do with the amount of time it is saturated in a given year. That landscape is saturated. And for me, that's a very easy distinction between a 30 to 40% mountain slope and a basin that's accumulating and that's accumulating materials and that is saturated for the majority of the year. And so maybe there's something else to look at there in terms of how we make that separation. This is why I asked the question about, does anybody remember why we use LFH and O horizons and why other systems are just using O horizons with suffixes, and then they separate those materials differently in terms of how they're classified into the different orders and grade groups. Paul, yeah.
Yeah, so after this point came up, after you asked that question, I was flipping around on my computer, and so if you go back to an earlier version of the Ag Canada describing soils manual it does have an appendix by Bernier, and that's dated 1968, which is about humus form classification, and it uses LFH terms there. So that's late 60s.
Yeah.
And
yeah,
it also, and it cites a National Soil Survey Committee meeting. So for
yeah,
what it's worth.
And in the 1968 National Soil Survey Committee meeting, they referenced the Bernier report. So, but Paul, if you could make that, do you have you have an electronic copy of that 1968 manual?
Yes, I do. I'll send it to you and you can post it.
Yeah, that would be great. Thank you so much, Paul.
Yeah.
We have another question from Constantine, or a comment from Constantine.
It's another comment for the cryosolic soils. I'm just concerned about growing number of subgroups being applied at the same time. This is the only order in Canadian system so far, before the 4th edition, that has more than 2 subgroups modifiers applied at the same time. All other orders have maximum of 2, let's say Glade, Rega, brown Chernozem. And Cryosols have already 3, if not 4 subgroups at the same time applied. We have this issue with anthroposolic soils classification. We are struggling with it. It could be up to 5, and then like definition of individual soil becomes like really descriptive and very cumbersome. So it's just a warning. Be careful, be considering that, and we may need even simplification rather than complication of the cryosolic order. But I do support adding folisolic subgroups because it is symmetrical to organic soil order. So saying that, I like to bring your attention also to the Canadian system. By definition, from the very origin and the philosophy of it, is features based. All the processes are implied by measurable, observable, or measurable in the lab or observable in the field features. When we say that days of water saturation or period of water saturation per year is a diagnostic criteria for something, that means I have a piezometer set up there for at least 2 consecutive years, and I have measurements for that. So classifying soil and field becomes impossible. I don't think it's following the philosophy of Canadian system of soil classification. Same to the picture on the screen. Are you saying that as a field pedologist, I need to be familiar with classification of bryophytes, being able to classify them and say this is sphagnum such and such and such compared to this is knight's plum and this is feather moss and this is other moss, and somewhere in Canadian system would be definition that feather mosses or brown mosses are included in classification of LFH versus O. I think it's beyond the scope of Canadian system. We need broad definition that is possible to do without knowing botany to the degree that I need to separate different types of mosses or lichen or whatever it could be. So far, it is not in definition whatsoever. Is it brown moss or sphagnum? And I like it that way. That makes it observable, measurable by people who actually have qualification of that kind. I'm not specialist in bryophytes. I'm not for sure. But to my understanding, not all parts of live moss stem are green. It's the parts above ground exposed to the sunshine that are green. And they could be alive parts of stem that are below the ground and they're whitish, brownish, same as roots of a tree. They could be dark brown. That doesn't make them dead. They are just part of life organism. And that concerns me. I agree with concern that was expressed here that upper part seems to be alive on this picture, and it's maybe not part of soil, but rather vegetation growing on soil. That's it. I just concerns, no solutions, just questions and concerns. Thank you.
Thanks, Konstantin. Scott, I saw your hand go up there with one of those comments.
Yeah, I'd just like to echo something that Konstantin just said, and that was that in the US taxonomy, many of the criteria involve long-term monitoring. You know, you need to know temperature regimes, you need to know moisture regimes over, you know, long periods of time, or in some cases for a specific period of time, like during the growing season or during the winter season. And so that's why, you know, the idea that our taxonomy is based on observable features in the field, and you may only be in there for a few days, it really makes that approach of having the taxonomy based on long-term monitoring activities, you know, very, very difficult for us in most of our cases. So just advocating to keep it the way that it's based on observable features in the field and not sliding into the requirement for long-term monitoring data to support it. In most cases, there might be the odd case where we need that. And in fact, even with the cryosols, to some extent, you know, it's always been a problem. Paul was very careful with his terminology, talking about the seasonal frost, because these things are frozen in the spring, but that frost layer drops during the growing season, during the summer season. And you're often never sure whether you're looking at permafrost or just seasonal frost that hasn't thawed yet. But we did this work in late August. So by that time, certainly middle of September, when you do encounter frost, you're hitting what you could be confidently call a permafrost table. It's not going to thaw much deeper. So again, for the most part, observable features is what we should base our taxonomy on. And I think pedologists need to have some understanding of botany and the vegetation that's growing on a site. Maybe not to be able to classify the bryophytes necessarily, but certainly to be able to identify, as I think we've done here, well, those mosses that we find in well-drained conditions versus those that we find in poorly drained conditions. So there is some need to be tuned into the other aspects of the ecosystem.
Paul Sanborn, I saw your hand go up there. You had a response.
Yeah, so maybe there's a cultural difference here, but in British Columbia, where pedology tends to be mostly done in forested environments, and we're practitioners who work either in government or academia or in the consulting sector, are primarily working with forested environments. And being able to distinguish between feather mosses and sphagnums, that's the kind of basic ecological knowledge that any undergraduate forester would be expected to have as just part of being a capable field person. So, you know, that's just background knowledge that we would sort of assume. Now, don't ask me which sphagnum it is. That's specialist knowledge, but I'm pretty confident if you took me into a bog, I would be able to recognize sphagnum. Or in environments where like the one I described in Haida Gwaii, you know, I was working with an ecologist at the time, and you know, my calls were verified by his. So yeah, I don't know what more I can say. This is just stuff you pick up from the fellow experts that you hang around with when you're in the field.
Yeah.
Thanks, Paul. I will point out also, Scott, associated with your comment about long-term monitoring, that there are distinctions, restrictions with certain soil orders with regards to soil moisture and soil temperature regimes across the country, which are things that are based on long-term monitoring data. You have to be, that you won't know if you're just standing in the field, right? So there are still aspects of our taxonomic system that aren't quite there yet that still do require long-term monitoring or long-term climatic data of some sort. And specifically with that one is, you know, the the restrictions on, for example, the occurrence of chernozemic soils across the country is one of them, right? They're restricted by moisture and temperature regimes, and so there are still some aspects. Most of the, I guess, most of the aspects of soils that we describe in the field are not related to that, but there are still some of those restrictions that are in there that are not observable morphologic characteristics, but are based on long-term monitoring of certain aspects of ecosystems.
Yeah, I appreciate that, Dan. And I was thinking that when I made that comment that there are some temperature requirements for chernozems in particular. So yeah, we're not 100% observational only, and I appreciate that.
All right, well, we've got 5 minutes left and 3 comments. We're not going to get to any votes today, but this has been a good learning experience for going forward and how much we can actually cover in a 2-hour session. So let's go to Paul, and then Richard, and then Jim, and then we're going to have to run because I have another meeting.
Okay, I'll try to be quick here. I'm going to expose my predilection for wanting to understand process, but I don't really feel in this particular case, the type of moss, the ability to identify that type of moss, which by the way, I agree with, competent podologists are probably going to associate feather mosses with uplands and sphagnums with wetlands. But regardless, I mean, looking at the picture, you don't need a long-term monitoring study to understand that that is a cold site. And with respect to our massed averages across the country and stuff, those are well established. In the past, climate change may change that, but those are the kinds of things that are established academically, and then the lines are drawn, and you work within that context. But in the specific example of these accumulations of quote unquote upland mosses, feather mosses, the dominant process there suggests cold temperature and or water presence is leading to the accumulation of that organic material regardless of its source. And what we have is an organic layer predominantly made up of a bryophytic substrate. And I come back to the original question, is it appropriate to use LFH to a bryophytic substrate? And so, that's kind of the rub for me right now, is and not disrespecting the green tops versus not. I mean, try to teach an undergrad student how to tell where to draw the line at the bottom of the active layer of the moss mat. You're pretty much telling them to remove the green. I understand there's more to the living part, but you can't. That's difficult for most people. So typically it's remove the salad guys and start your level from there. Once you get to a certain level of decomposition, telling mosses apart them can be quite difficult too. At the fibric stage, of course you can, but again, we come back to the point that from a process standpoint, we have an accumulation of organic materials. What is driving that? What are the climatic variables? What is the vegetative variables driving that? And you call what you see, despite the fact that we can both agree that these things are occurring in ecological positions in the landscape that might be called uplands and might be considered well drained at the surface. But I would argue again that I haven't been to this site, but I've certainly been through the shield and through the thermokarst and in the contiguous and non-contiguous permafrost regions, and these species are predominantly laterally rooted. So it only has to be dry in the root zone above the frozen layer for these species to act in an upland manner. And I'm talking the upper woody species, the tree species, the overstory. But at the end of the day, you've got mosses that are the organic material that is accumulating. Why is that accumulating? It's either cold or wetness. And so we recognize that, great. We decide on a paradigm to describe it. The only question is LFH the right paradigm? Thanks, guys.
Yeah, thanks, Paul. That goes back to right back to the definition, the actual definition of LFH, not necessarily folic material or where it belongs. But yeah, the kind of the first part of our discussion today, the definition of LFH includes with or without components of mosses. And so the question is that appropriate? So Richard.
I'm really enjoying this discussion from this perspective. I think we're going to be facing a similar conundrum when we start delving into the modeling and laying and how what we really mean by these and what the significance of them. And if this conversation about adding the potential folic dimension to the cryosols, you can't ignore then also reflecting back on what's happening in the organic order. And I look at folisols and they say very clearly, folic materials are formed under ecosystems different from those of peat materials. And so I know there's been several people talking about the same thing. And the previous time I mentioned this notion, do we really understand what the meaning of certain types of mosses is? And how are we interpreting them? We're using these terminologies, we've got these terminologies, I think we've got a first approximation of how they were being used. And I think we're getting to the point where we're realizing that the way that the O's or the LFHs are being employed has to have a greater rethink. But in a sense that if we are wanting to be able to say that, yes, we've got a cryosol that is an organic accumulation, and so it's just not a litter layer, a thin LFH layer. So we're getting into a little confusions there that we're actually moving into what is an expression, a soil that has a dominant character to it that's organic. It's not wetland and it's got permafrost. So I think it's only logical. You have to categorize it as a frozen type of a variant of a folisol. But when you see the material that's there and it's confounding you because you've restricted your definition of what is an LF or H vis-a-vis the various types of O's, then we're in this circular conversation. We can't ignore going back and looking at what do we really mean and what do we by these terminologies and what do they tell us? What are they telling us? What are they proxies for? Because ultimately we're describing things because they're proxies of something, which are ultimately telling what kind of processes have gone on in that point in the landscape and may still be dominating processes in that landscape.
Thanks, Richard. Paul, can you unshare your screen for us? I just wanted to show you this. So if you recall, there was that modification to the definition in the paper. The reason I changed I requested that change was to be consistent with the description of some of the other organic cryosols. So you can see here a fibric organic cryosol. Organic cryosols are identified by the following properties. They have organic layers thicker than 1 meter. They are composed dominantly of fibric materials in the control section below a depth of 40 centimeters. And so that's why I had proposed the change for a folic organic cryosol. We retain the same definition as the other organic cryosols, but we specify that it's folic material. So we might have to play around a little bit with the wording if we think that's no longer appropriate. So we'll loop back in with you, Paul, on that, on how we can potentially modify. But this is the rationale for why I had asked for that change in the paper, was to align it with the other definitions. And so on that, I think I see Brandon's back on. I think we'll adjourn for today. Some very good discussion. Again, the video will be posted. We'll send a follow-up email with the information on how to get to the video if there's parts that you want to revisit and re-listen to. And I think we can also capture the chat. Brandon, do we capture the chat as well in this?
Possibly.
Okay. Before leaving the meeting, there we go. I don't know. I saved the chat. So there's a button at the bottom that lets you save the chat. So I'll also keep a copy of the chat, and we can make that available as well. And so I think for this first meeting, I don't think I'm not gonna send out any voting for accepting or rejecting. I think we'll move that to a further meeting. I'll have a chat with Brandon and maybe Angela on that.
Yeah, I think for the proponents, it'd be a good idea for you to come up with an actual set of words or whatever so when we do go to that voting process that we have something to work with. So come up with what you think you want to have it as.
Yeah, and I think I had reached out to Paul and Jim about proposing a motion that could be seconded and then voted on, kind of like we do at the annual general meetings for motions during the business meeting. And so I was going to follow that type of a format, but realizing that and I had those questions already kind of laid out, but realizing that this is actually much more dynamic, I think, than what we thought. And like, for example, the definition of LFH would need considerable revision before we could vote on it. And so I suppose we can try to come up with some boxed questions. I'm just not sure that at the end of our discussions we'll be at a point where we can actually do that. It might always have to be kind of a subsequent meeting to finalize what the actual question that people are voting on is.
And also, if there's any interest in participating on the refining the LFH horizons and looking at humus forms, maybe contact us or let us know. I have Margaret and Brian down as people that are interested already. But yeah, we should probably form a small working group on that.
Yeah, so I think, Brandon, we can do that again I think we can send out an email to the membership again and ask to see who wants to participate, because I think we're going to need more discussion on that for sure.
Yeah.
Okay. Thanks everyone, and we're on next month again. I'm not sure exactly of the date, but it's the third Friday of the month, and we will see you then. Thank you very much for your time.